Review the story you wrote from problem 2.1 and after examining the graph more closely from 2.1 to 2.5, what other information can you add to the story? So you're going to work with your team to answer the following questions. Try to explain using the vocab you learned in the lesson. So things like concavity, concave up, concave down, the extrema, maximum and minimums, increasing and decreasing. Using these words to help answer these problems is good. So in this case here, the first one says, how fast was Riley driving when she was 30 minutes into her drive? So when I look at 30 minutes, that's right here. I'm just going to take kind of like an estimate here of, let's say just the kind of this point right here. If I were to take the speed, right, speed is in miles per hour. So I'm going to just do kind of the slope-ish at that point. And so when I'm looking at that, Riley goes about 2 miles in what is this? 1, 2, 3, 4, 5, 6, 7, 8. So goes 2 miles in 1/8 of an hour. And so just to simplify that to miles per hour, 2 divided by 1/8, 1/8 is the same thing as 2 times 8 over 1. So I'm going to, again, estimate here about 16 miles per hour maybe. For B, when was Riley's speed 0? A couple of different spots here. I would say, at the very beginning, at the very end, right? Always starting and stopping at 0. But also the important part here is what I highlighted in purple is when they're at a constant distance, they're going nowhere. They're not going away from home and not going towards home. So I'm going to assume here that it's at 0 for B here in that purple area right there from 1 to 1.25 hours. Was Riley ever speeding? I don't know what the speed limit is, dude. I can't answer that. This is a bad question. I can't do anything with that. When did Riley go from speeding up to slowing down? Okay, so speeding up, so this is kind of a tough one, actually. You might think increasing to decreasing, but no. Speeding up is actually we're getting faster and faster. Actually, let's go a different color here. We're going faster and faster and faster and faster and faster and faster, and then we start to slow down from here to here because we're slowing down, meaning we're getting less far from home over time. So the actual words that we can use here are when it is concave up, we are speeding up. When it is concave down, we are slowing down. How far did Riley travel during her 2-hour drive? Oh, wait, hold on. I got to go back to D really quick because think of it this way, right? Changing from concavity here is actually different. So in the brown here that I just did, that's slowing down, even though at this next part here, even though it's still concave down, this orange that I'm highlighting right now, that's actually speeding up because they're speeding up going towards home though. So it's not necessarily concave up and concave down, but it's a section of that concave up. And we'll talk about that more in 2-7. Okay, so from E, how far did Riley travel during her 2-hour drive? I guess, let's see here. How far did you travel? It kind of depends. I mean, you could try and answer it because you could say they traveled whatever, 5, 6, 7, 8 miles away and then traveled 8 miles back. But that isn't under the assumption that we went from the house to the store in a straight line and then a straight line back, right? Because technically, when you look at roads, they go all over the place. So how far do they travel really depends on how many turns they made and how far left to right they had to go. But when we're thinking about it, if we're not talking about going in a straight line, we can't really answer that question.